Good afternoon, class. Pre-calculus practice test number 4, module 4, covering chapters 8 and 9. 5.4, right triangle trigonometry. 8.1, the law of sine. 8.2, the law of cosine. Here's the second part. All right, so angle of elevation and depression. By definition, angle of elevation is the angle formed by the line of sight and the horizontal plane for an object above the horizontal. So this angle, you look up in essence. Angle of depression is the angle formed by the line of sight and horizontal plane for an object below the horizontal. So in essence, you're looking down. So that would be an interesting way of putting it. The cat looking up. This angle is the angle of elevation, and the bird looking down. That would be the angle of depression. Or in this case, looking up for the plane, looking down for the dog, and that is the simple definition. Now, here's an example. An aircraft is spotted by two observers who are 1,000 feet apart. As the, so 1,000 feet. As the airplane passes over the line joining them, each observer takes a sighting of angle of elevation, 40 degrees, 35 degrees. As indicated in the figure, how high is the plane? So let's define our variables. So this is the height we want. This side, we're going to call it y, and we are going to go with the sine law, sine A over A, sine B over B, sine C over C. If this is 40, this is 35. This, first of all, each one, we can calculate. This is 90 degrees. This is 90 minus 35. This is 90 minus 40. And this is 180 minus the sum of those two. Just add up those two. So for example, right here, this angle is 105 degrees. Two ways to look at it: add these two, subtract it from 180. Or as you can see, 35 and 55, they add up to 90. 30 and 40, they add up to 90. So this must be 105. And so you have this angle. You have the opposite side. So sine of 105 over 1,000 is, you want the y, so in order to get the h, so sine of 35 over y, cross product, means if you multiply these two, divide by this one, it is y. You put it into a calculator and you find p, r, or y. Now, it is extremely important to know when you're calculating intermediate steps, do not do the rounding. Carry as many decimals as you want. At the end, if you need to do the rounding, otherwise you are going to make a mistake as far as the final answer is concerned. Now, we want the h. Sine of 40 is h over y. And we have found y to be 593.81 roughly. So h is the product of these two. And putting it into a calculator results in 381.69. As always, you have to put the proper units in feet. Two homes are located on the opposite side of a small hill. To measure the distance between them, a surveyor walks a distance of 50 feet from house P, the first one, to point R, uses a transit to measure the angle P or Q. The angle between the two houses in essence is 80 degrees from two different, from this point R, which is found to be 80 degrees. And then walks to house Q a distance of 60 feet. So needs to find out what's the distance. How far apart are the houses? Draw a diagram. And again, remind you of the sine law, cosine law, and so on. And I hope you see, we're going to rewrite this in the following manner. So because If they don't give you that, you should see PQ moving this way for 50 feet. Let's call it R, moving this way. This makes an angle of 80 degrees, and this is 60 feet. It is side angle side. We use the cosine law, A squared equals B squared plus C squared minus 2BC cosine A. So PQ squared is one side, 60 squared, plus the other side, 50 squared, minus 2 times the product of the two, minus 2 times 60 times 50, and then cosine of 80 degrees. And you put it into a calculator, you get the answer, and you take a root. So the answer is 5058.11. You take a root, and it becomes 71.12. So the distance between the two is 71 feet, 71.12 feet. Two boats that are leaving the harbor in different directions make an angle of 135 degrees. One has traveled 300 feet, the second one 350 feet. How far are these boats? So you have to draw a diagram even if they don't ask you. So you have to set up in the following manner. So one is going this way, one is going that way. And as we call them ABC, the angle in between is 135 degrees. This covers 300 feet, this covers 350 feet, and we are interested in finding BC, or let's call it A. And obviously it's side, angle, side, and we're going to use cosine law. A squared equals B squared plus C squared minus 2BC cosine A. So A squared is one side, 300 squared, plus the other side squared, 350 squared, minus 2 times the product of the two, 300 and 350, and cosine of 135. Of course, cosine of 135 is the same as cosine of 45, but it's negative in the second quadrant. So cosine of 45 is square root of 2 over 2. This is negative square root of 2 over 2. You put that into a calculator, you find A squared, you take a root, and A, the distance between the two boats, is 600.83 feet, almost 601 feet. Two cars leave an intersection together traveling on courses with an angle of 45 degrees between them. If each travel 500 feet, how far apart are they? Draw a diagram. So one is going this way, one is going that way. They make an angle of 45 degrees. Each one is going 500 feet, and we want the distance between the two. We call it a question mark. Again, we are going to use the cosine law. Okay. So A squared equals B squared plus C squared minus 2BC cosine A, or how about C squared is A squared plus B squared minus 2AB cosine theta. This is another way of writing it. Again, just in essence, we are calling this side the C. This is A, this is B, right? So the missing side must be C. And so 500 squared plus 500 squared minus 2 times the product of the two, cosine of 45. Again, cosine of 45 is square root of 2 over 2, but you're going to put this into a calculator, you come up with the answer, you take a root, and C becomes 382.68 feet. You have to work it out, everybody. Okay, we're going to look at a similar situation. Two cars leave an intersection together traveling on courses with the angle of 30 degrees this time between them. If one travels 1,000 feet and the other one 720 feet, how far apart are they? Draw a diagram. In this case, again, one is going this way, one is going that way, making a 30-degree angle between them. One covers 720 feet, while the other one 1,000 feet, and we are asking to find the distance between the two. Again, C squared equals A squared plus B squared minus 2AB cosine theta. This time, okay, so 720 squared plus 1,000 squared minus 2 times the product of the two, cosine of 30 degrees. Again, put it into a calculator, come up with the answer, take a root, and C becomes 520.89 square feet. George standing 35 feet in front of a house and notices that the angle of elevation from eye level to the top of the house is 60 degrees. Find the height of the house, draw a diagram. And again, reminding you, here's what's happening. We're looking this way. This is the horizontal line or line of, or the horizontal plane. And if you're looking up, angle of elevation, the object is at top. And if you're looking down, angle of depression. So we do the drawing looking like that. And this angle is given at 60 degrees. The distance is 35 feet here. H is of interest to us. So we want to find H. Tan of 60 degrees is the opposite H over the adjacent 35. So H is the product of these two. This is a cross product. And tan of 60 degrees is square root of 3. So precisely 35 square root of 3, roughly 60.62 feet. This is an exact answer because tan of 60 is a common arc. George standing 27 feet in front of a house on a hill and notices that the angle of depression this time from eye level, the top of the house to its bottom is 73 degrees. Find the height of the house, draw a diagram. So this time we are looking down, and that means we are creating an angle of depression happen to be 73 degrees. And we are 27 feet away from the place, from the house, and we are asking for H. Again, tan of 70 degrees or alpha is the opposite H over the adjacent 27, which makes H the product of these two numbers. H is 27, tan of 73 degrees. This is not a common arc. You have to use a calculator, and it becomes 88.31 feet. As far as the number of decimals, again, you carry many, 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 many decimals, always. Recall, two parallel lines AB and CD intersected by the transversal line GH. The figure shows two parallel lines AB and CD intersected by the transversal line GH. Corresponding angles are equal if the transversal intersects at least two parallel lines. In short, you have two lines and a line that cuts it. It creates 8 angles. So quickly, these two are equal, these two are equal, these two are equal, these two are equal. These two, they add up to 180. This one and this one are equal. This one and this one are equal. I hope you see that there are 8 angles. They are either equal or they add up to 180. They are supplementary angles. That's all. Corresponding interior angles found at the inner side of the intersection between the parallel lines and the transversal. Corresponding exterior angles found at the outer side of the intersection between the parallel lines and the transversal. So the pair of corresponding angles in the given figure having the same color are 1 and 5, 3 and 7, 4 and 8, 2 and 6. Okay, corresponding on the same side. In the given figure, of course, AB is parallel to CD. This is the notation that says parallel. Thus, 1 and 5 are equal. Angle 1 equals angle 5. Angle 3 equals angle 7. Angle 4 equals angle 8. And angle 2 equals angle 6. Alternate interior angles are also equal. 4 and 6. Angle 4 and 6 are equal. Angles 3 and 5 are also equal. They're called, that's the terminology, alternate interior angles. Same side interior angles are supplementary. 4 and 5, they add up to 180, 4 and 5. 3 and 6, they add up to 180. Alternate exterior angles are equal. 2 and 8. 2 and 8. 1 and 7. Same side exterior angles are supplementary. Okay, same side, okay, angles, exterior, okay. For example, 1 and 8, they are outside the two parallel lines. 1 and 8, or 2 and 7. So that's pretty clear. Now we want to look at this example. A balloon is flying at a height of 600 feet directly above the Statue of Liberty. What is the angle of depression from the balloon to some airport that is 5 miles from the Statue of Liberty? Of course, we have to draw a diagram. And of course, this is in feet, this is in miles. We should know 1 mile is 5,280 feet. So here's the drawing. So here's the balloon. Here's the height of 600 feet. Here's the airport located 5 miles away. Here's the angle of depression at theta. Now, we also should recognize this one is equal to theta because these two lines are parallel, okay? And this cuts them, and alternate interior angles are equal. So that means instead of calculating this, we're going to calculate this one, and it's equal to that. Tan of this angle is the opposite 600 feet over the adjacent 5 miles. However, we have to go with the same units, and we are going to change this to 5 times 5280 feet. Put it into a calculator with a bunch of decimals, 0.0227272. And so what is this angle? If tan theta is that, theta must be tan inverse of this number. Putting it into a calculator, this is the answer, and let's say we stop right here next to this 9, we get 1.302 degrees. It depends on how many decimals they ask you. Navigation and surveying, I want to remind you what that is. A bearing is used to represent the direction of one point relative to another. There are a couple of methods. Method 1. The direction or bearing of a point is the number of degrees in the angle measured in a clockwise direction. Clockwise, going this way. From the north, vertical line, to the line joining the center of the compass with the point. So basically from the north, you just figure out what's going on, how many degrees, and that's it. So let's look at this. Obviously, P1. So we start with north. P1, what is this distance? In angle, 30 degrees. That's it. P1 is 30 degrees. Now, P2. This angle. How do you come up with this angle? This is 50, and this is 180. So 180 plus 50, everybody. This one to here is 180, and then this adds 50, 230. P3. P3, we're going to continue. So same thing, we're going to continue, and we go here. I hope you see that this is 70 degrees. So this must be 20 degrees. So if this goes 270 degrees plus 20 is 290 degrees. Or, so I want to make sure that it's 290 degrees. There are two ways to find that. One way, as I mentioned, is 270 plus 20. One way is that this angle is 70 degrees. So it is 360 minus 70 degrees. So one more time, I want to make sure you understand. So this entire angle is 360. Subtract 70, you get 290. What about P4? Let me erase my work. P4. Okay. If this is 20, subtract it from 180. That's the fastest and easiest way. 20 degrees, subtract it from 180, you get 160. And we're done. That's the first method. Here's the second method. Direction or bearing of a point O to point P equals the acute angle theta between the ray OP and the vertical line through O, the north-south. In other words, let me erase my work. You either compare it to north or south. Which one? The one that is the closest. For example, the first one. You see that P1 is closest to north. So you're going to say north, okay? To the right is east, and you put the number 30 degrees in between. North, 30 degrees east. What about P2? Now, P2, is it closer to north or south? It's closer to south. So you have to start with south. What is this angle? 50 degrees. So you first mention either N or S, then the angle, south 50 degrees. If we are going to the left, that means west. What about P3? Okay, closest to north or south? North. So you're going to mention north, the angle 70 degrees. To the left of it is west. P4 is closest to S or N? S, the south. So S, 20 degrees, the right is east. That's how you do the bearing. Non-application. So this is what you get, okay? Those are all the answers. A rocket takes off at a bearing of north 30 degrees east, going this way 30 degrees. So north 30 degrees east this way. After flying for 900 meters, the pilot turns 90 degrees and heads northwest after flying for 1,000 meters. What is the new bearing of the plane? Draw a diagram. So we're going to reread this again. So first we are going in this direction. And I'm going to remind you of that. Okay, so this is north, 30 degrees east. So we are going this way. Okay, just as an example, this was what? South, 20 degrees. Going this way to the right is east, just as an example. We just did it in the previous page. So we are going in this direction, north 30 degrees east. That's the first. After flying for 900 meters, so we're going to go for 900 meters this way. Okay, north 30 degrees east. Then the pilot turns 90 degrees. When you turn 90 degrees, this is 90 degrees. You either go up or down. Which way do we go? Turn 90 degrees and heads northwest, so this way. This is 900 meters. We are going that way, okay? Because they said so. How far do we go? 1,000 meters. What is the new bearing of the plane? So you connect the 2 points, and it's going north to the left west. We need this angle. So we call this angle alpha. The answer would be north alpha west. Now the question is, how do you find alpha? That we are going to discuss. So understand that we were going 30 degrees, north 30 degrees east. So this is 30 degrees, and this entire angle, we're going to call it theta. And this little one is 30 degrees, right? So I hope you recognize that alpha plus 30 degrees is theta. Therefore, alpha is theta minus 30 degrees. Meaning, find theta, you're practically done. How do we find theta? Well, look at this triangle. Tan of theta is the opposite 1000 over the adjacent 900 meters. You drop a couple of zeros, and they first maybe we drop a couple of zeros and 10 over 9. So theta is tan inverse of that. Tan inverse of 10 over 9, roughly 48 point. Let's see, if you stop here, 0, 1. If you stop here, 0, 1, this changes to 3 because next to it is 7. In any event, what is alpha? This number minus 30 degrees. So 1801. So you say north alpha 18.01 degrees west. That's how we come up with the answer. It is extremely simple, everybody. An aircraft leaves an airport from a runway with a bearing of north 40 degrees east. North 40 degrees east, so in this direction. After flying for half a mile, the pilot turns 90 degrees and heads towards southeast. After flying for 1 mile in this direction, what bearing should the control tower use to locate aircraft? Draw a diagram. So first and foremost, we're going to read it again. North 40 degrees east. So this is it. So we are going in this direction after flying for what? Half a mile. So this is 40 degrees and we go half a mile, 40 degrees, and we are going to go half a mile. Then we turn 90 degrees. When you turn 90 degrees, class, you make a 90 degree either up or down. Which way do we go? Head towards the southeast, so this way. After 1 mile, so this distance is 1 mile. And this is a 90 degree angle. This is 1 mile, everybody. What bearing should the control tower use to locate the aircraft? Let's connect these 2 points. Okay. And so we are looking for this angle. Okay, we have this. Okay, this is an angle. This is an angle. And we call this angle alpha. If we find this angle, then we are going south, alpha, east. South, alpha, east. All you have to do, find alpha. Now, how do we find alpha? Well, this is 40 degrees, everybody. This is angle theta. This is angle alpha. The three, they add up to 180 degrees. So this is theta. The sum is 180. This one, and this one. The blue one, the green one, the red one, they all add up to 180. And as long as we have theta, we can get alpha. So how do we get theta? Look at this triangle. Again, tan of theta is the opposite 1 over the adjacent 1/2. And as you know, 1 over 1/2 is 2. Therefore, theta is tan inverse of 2. Putting it into a calculator results in 63.43 degrees. So we are going to subtract 40 from 180. We're going to subtract theta 63.43 from it. In other words, add 40 to this one and subtract it from 180. Alpha is 76.57 degrees. So south alpha east becomes south 76.70 south 76.57 degrees east.